this is the first talk that I give, like, you know, at a meetup or any event this year, so yay. Before I start, I will always say that the first slide is the most important slide because you have all the things that you need here. You can contact me if you have questions afterwards or something. And then there's also the link to a GitHub repo, which is I gotta show you hopefully a little bit of the first notebook. But if you want to finish at home, there's homework for you, so you can actually finish it because I don't think I have time to show you everything. Without further ado, let's jump into it. So I'm Cheuk, hello. I work on Numba. My colleague Valamri is here as well, so you can also ask him questions. I love open source projects. I've been involved in various projects in the past. I also love organizing events, so I've been involved in different events in the past as well. So what is Numba? So this is what I copy from the documentation page, so you don't have to take a picture of it, you can just find it on the documentation page. So Numba, the way I put it up here, because first of all, it's explained very well what is Numba. It's an open source JIT compiler. So, okay, open source we love, but what is JIT compiler? That translates a subset of Python and NumPy code. Oh, NumPy, oh good, we use NumPy, so that's good for us. Into fast machine code. Fast, we love fast. We want the speed, so that's a good thing. So we love it, right, already? Okay, but before that, let's talk a little bit about the JIT compiler. So JIT, we heard about that before probably, but what does it mean? So JIT means, so it's just the first letter of just in time. So it's a just in time compiler. So what does it mean is that, so there are other languages other than Python that they may have to, you may have to compile the code before you can run the code, which is not the case in Python. So in Python, there are these kind of things that pop up. It's called just in time compiler, which means that when you use it, so when your Python code run, so when it sees that, oh, you have this thing that you may want to compile, so it will just compile when it sees it. So it's just in time. So just like, it doesn't do it in advance, it's do it last minute. That's what it means. So why Python doesn't compile the code? Why, for some of you use C, then you have to compile before you can run the code. Why we don't do that in Python? Fun fact, compiling code actually takes time. Because Python, I think when it started, it's very like beginner friendly. It's supposed to be an easy programming language to learn. So if you ask the people who are new to coding to compile the code, it actually very difficult. If they want to fix a mistake and compile it again and stuff. So Python doesn't do that. So it's good in some scenario, but sometimes it will give Python the reputation of being slow, right? So sometimes you heard that, oh, people comment about Python is slow. Well, because compared to those programs that has been compiled and then run after, then they are faster after they are compiled. So JIT compiler try to solve some of these problems. So if your code have some functions that got used more than once, so you can actually save time by compiling that chunk of code. So the first time is slow because you have to compile it and then you run it, so it's slow. Compiling is slow. But because you run it the second time, the third time, the fourth time, it doesn't need to be compiled again. So it will have the fast speed, the same as a compiled code. So if you use a lot of looping, then this is something that you want to use. So Numba, you can see from the first paragraph that I brought up, it works with NumPy. So Numba is designed to use together with NumPy. So it handles a lot of things that numerical calculation and the things that you use NumPy for very well. But there's another thing. If you look at the documentation, they said that don't use it with pandas because the pandas data frame, Numba doesn't know what it is. It won't be compiled, it won't be fast. So also, if you have a lot of looping, like I explained just a few seconds ago, that you can take advantage of compiling code with Numba. So in Numba, there's actually two modes that you can use. So it's called object mode and non-Python mode. So what are they? more terms. object mode means that Numba won't complain when it sees a Python object. Because, well, I think object mode means Python object mode, so it will handle the Python object for you. But the drawback is that it's not guaranteed that it's going to be fast, because some Python objects can't be optimized by Numba, so it would just let it be whatever it is, like, so it doesn't do anything for them. If Numba sees that, oh, there's some potential that you could speed up, then it will try to speed up that bit for you. But it doesn't guarantee the JIT component. It doesn't guarantee that it will be compiled. So most of the time, when we use Numba, we would try to use the no Python mode. So no Python mode means that it will be fast. But the drawback is that it doesn't recognize all of the Python things. So some Python C API doesn't have access, so it can't be speed up. So a lot of times when you try, maybe like first try to use Numba, you come across a lot of errors that it says we can't compile. Sorry, you know that there's something wrong. So a lot of times you can fix it by just switch from no Python mode to the object mode. But again, like if it doesn't speed up your code, then why are you doing it? So that's why we have to learn how to use Numba effectively to try to take advantage of the no Python mode. So, the two modes is actually when you read the code that is using Numba, you see that there's decorators that are used. So one thing that you see a lot is the @JIT. So is the decorator. Then you put it like in front of a function. You have the add thing that's actually a decorator. So @JIT. So just like that, like using all the default settings, it would just use the object mode. You can actually change the JIT decorator into a no Python mode, but you have to specify it. So it will just do what the object mode does. If it if it doesn't compile, if the code is not compilable, you just let it be. It's not faster, but if we see some potential, maybe it could help, but no guarantee. NJIT actually is a shorthand for setting the no Python to true. So it's always using the no Python mode. So it will guarantee the high performance, but again, if sometimes you get your code getting the error saying we can't compile, so you have to solve the problem. So you have to know when to use it, when to not use it. Also, a quick note about we love GPU, right? So if you use it with the GPU, Numba actually support it, but we are not going to dive into using Numba with CUDA GPU here. There's a talk recording that if you're interested, if you go to the repo, you will find the slides and you can go to the recording to know more about it. So this is the documentation I mentioned. We would be using a lot if you are trying to doing this at home, but since I'm going to run it a little bit here, so you don't have to use the documentation right now. Maybe when you're doing the homework, then you will need it. So these are your homework, so you can do it at home. First of all, installing Numba, just pip install or conda install if you're using conda, for those of you. But yeah, I've already installed it, so we don't have to do it now because I have no internet here actually. Let's see. This is the very basic of how you can use Numba. So I'll just run it and I'll explain the code, what's going on here. So you see we have the JIT. So I import JIT, the decorator from Numba. Now I can use it as a decorator like this. So I've already showed it in the slides that you have the @JIT in front of your function. So that's the decorator. And then this one, actually I'm using the no Python mode. You can also use NJIT. It's basically the same thing, but they're just interchangeable. So just, I don't know why. Just copy the code. So here we have a very large NumPy array here, X. You can see that it's quite large. It's it's not huge, but it's a kind of a big chunk of size. So normal, we don't use the decorator, so just run normally, like a vanilla Python. You don't do anything, just let Python do whatever they want. So it's that. And then we compare it with the go fast, which is the one we use the compiler. So this is just like calculating time. So we have to do it like 3 chunks here. So what are these doing? So the first one, we are of course measuring the normal one, the original one. The second one, we measure go fast the first time it got executed. So this one, because again, like I explained in the first slides, yeah, maybe. So yeah, so it will actually compile the code. So actually, it should not be fast the first time, but the second time it should be really, really fast. So let's see if that's true. So this is your baseline here. So it's you know, for those scientists here around you, it's like e to the power of -3, -4. So it's like, you know, quite fast already. But if we run the you know, the compiling version the first time, it included compilation, it's actually much slower. It's like magnitude of 2 or 3 slower, so it's not good. But the thing is, after the compilation, it's e to the -5 here, so it's you know, two order of magnitude faster than the first one. So what this is trying to demonstrate, this part of the exercise trying to demonstrate, is that if your code doesn't run the second time, maybe you should not use the JIT, because you know it's not making it faster, it makes it slower, so your code will go slower. So we have to be smart when we use it. It's not a, you know, one size fits all thing. You have to think when to use it. So I have talked about that Numba is very good when there's some loop. So what happened here is that we'll compare the vector operation and loop operation. So as we know, if you are a power NumPy user, you know that the advantage of NumPy is that the vector calculation with NumPy is super fast, because it's not written in pure Python. It's actually written with other thing, Fortran maybe. So they're fast, right? Because you know they are plugins that make it fast. But so a lot of times when we're using NumPy, you know, some beginners may make a mistake to do some like element-wise operation that involves a lot of loops. That's actually slow. So whenever you're using NumPy, try to do vectors instead of looping. So this one, we are trying to do some experiment here. So I'm just going to run them because the last one takes some time. So maybe I won't have time to show you this. But anyway, so now let's look at it. So again, we have a very large array. So this one is like e to the power of 7, so it's a very long array. And then we are doing this, you know, again, you know, mathematician here, you know what this is doing. You know, cosine square plus the sine square is called indent. I don't know what that means, but I give back all my math to my teacher. But it's a very taxing calculation. That's what it is. So this is doing a vector operation here. You can see x is a vector, right? It's a NumPy array. So it's doing the vector operation. This is what you're supposed to do when you're using NumPy. And the time is decent. So it's a 197 milliseconds. So it's decent time. It's not too slow. You know, it's acceptable. But when you make a mistake and do element-wise operation like this one, right? So it's doing every single element. We do the same thing, but we use a loop to do it instead. This one is super slow. It's still running. It's that slow. So it's not good. It's 10 times slower. I've done it before, so it's 10 times slow. So let's stop it right now, because otherwise it will take forever. You can try it at home. It's really slow. It takes a few minutes to finish the time experiment. Also, by the way, time it is like the code will run multiple times to check the time. So you see that this one has been run multiple times. So yeah, so that's why it's so slow. It will take a few minutes to finish this one. Anyway, so now we want to see how we can save our day if we absolutely need to do some looping operation. What can we do to make it faster? So we use ngit here. So ngit, again, no Python mode, which is compiling the code, which is a good thing that we want. So let's run them all, and then we look at it. So first of all, the vector operation one, so it will get speed up as well. So we compiled it. So again, we don't measure it the first time because first time is slow, so we don't count it. So the second time we do the time it, so the second, third time, and like this time it, we'll run it again multiple times and give us a result. So, but it doesn't include the first time, so it's fine. So it's actually faster. You see, this is slightly faster than the original one here, right? So So it's slightly faster. But this is not what Numba is really good. Numba is really good. Is that when we have something like this, so sometimes, this one of course is a bit silly, we can do the vector one, but if you have to do it element-wise for whatever reason, then this looping can be speed up really fast by Numba. You see that this one is 122 milliseconds, just slightly slower than the vector one, right? Or even faster in this experiment, I don't know why. But it's actually comparably fast as the vector one, So it saves your day. So if you can't do vector operation, then and you have to do element-wise operation that loops for a lot of times, think about Numba. That may actually help you. So there are also other things that Numba incorporate to make it even faster, but these are not the star of the show here. You see that, for example, something we call fast math, which is, in the computer world, that's so complicated that I don't even understand, but you can read it yourself. So there's some compliance that is the hardware or whatever, like down to the machine code maybe, that needs to follow to make sure that your calculation, the precision is correct. But sometimes we don't need that precision because, we may actually truncate it at the end when we report the result anyway. So that precision is not that important. Then you can deploy this fast math option to make it slightly faster, because if we don't have to, be this IEEE 754 compliance, then you can swap the operation order and make it faster. This is what Numba is doing. So you see, we have this experiment that see the difference between the no fast math, the first one, do some, and then do some fast, which is the one that we use fast math option. So again, we have to compile them. We don't count the first one, so let's ignore this cell. And look at these two and see how fast it can be if we sacrifice a little bit of the precision. Yeah, again, it takes some time to run it. How much time do we have? Okay, maybe we can still go over this. Maybe I'll run the last one so we can go very quickly. So we'll just run this one. So okay, so now we have the result for the fast math. So you can see it's not a huge improvement, but it's still an improvement over the one without the fast math. So this is like really the last thing you can polish it to make it even faster. Another thing you can do with Numba is to use the parallel. Python doesn't do multi-threading by default. Python has a guild that doesn't do that. But because we're using Numba to compile the code, so you have the option to use multiple core. So you can set the parallel option into true. So we are using the multiple core. We're doing the same thing. This one very familiar. It's the thing we do at the beginning. So now we're using multiple core to see if it's even faster. So you see that actually here, can I compare the result here from here? Yeah, so this is the one that we do the same thing, but we use the compiler. So this here, I'm a bit lost. Okay, here, this is the thing that we use the compiler. We did the cosine thing, and this one is 123 milliseconds. This one is 43. So it's like. Maybe it's not 7 times faster, maybe the best result is 7 times faster, but it's still significantly faster. Again, but it may depend on your machine. I tried in my old machine, which is like only dual core, it's not that good. This is a newer computer, so it's slightly better. So you can try it at your computer to see how much improvement you can get out of the parallelization. So I think we are running out of time, right? No? I still have 1 minute, so 5 minutes for Q&A.
No, without Q&A.
Without Q&A.
You have plenty of time.
Okay, I have plenty of time, so maybe I can go to the next one then. I'm very fast, which is good. Okay. So this one is the. So this one is. So I don't know whether I can go through it in 5 minutes, but maybe I can. So this one is. When you do it at home, it's kind of like you can try to. Oh, so there's something at the end. It's kind of like a quiz. So I would definitely let you do it at home because I won't show you the answer. So this is like when you see something that goes wrong in Numba. So this is trying to help you to troubleshoot a little bit how to fix it. So this notebook, actually, the first thing is that sometimes, again, we try to use the engine, which is to get the speed from what we want, but sometimes it won't work. For example, you see this one works, but this one doesn't work. Because this one has something strange in here, right? So this is like, adding numbers, so it's supposed to take 2 integers, but what if I'm actually doing something weird that I add something that is not an integer? You get a problem. So this is something you may see when you use Numba, is that said that like it can't be compiled. So this very weird error message is saying that like, well, because it's not an integer, right? So we have problems. So here, what you can do. So for example, this one's supposed to have no error when you run it in pure Python, because I would convert it back into integer if I put a string here, right? So, but ngit will still not like it, because it doesn't know that, actually you get a warning out of it. Because this is not ngit, because this is jit. So this one, so it will still work like Python because it's using the object mode here. So you see that actually it will still work, but it will get a warning saying that something fishy there. Something is very, very fishy, and we are using object mode here, so your code won't be faster. So this is what it's warning you here. So all these style, like all these things above, you can read it yourself at home. It's just saying that when you have problems, sometimes quick fix, change it into object mode, but you will get a warning saying that it's not that fast. So yeah, I would say that most of the time, just look into your code to see why it doesn't work. Maybe you can fix it. If you can't, then I'm so sorry you can't use Numba to speed up here. So, but if you go further into this exercise, you see that sometimes you can find a workaround. So yeah, so this is, again, this is you have a problem that like you can't use. So yeah, I think I'm going into like solve the problem yourself territory here. So I'm not very keen on like showing you all the answers, because this is what you should try to do it at home. So yeah, so maybe I'll have more time to take questions. I think that would be a good idea. Yes. Okay. Sorry about shortchange you for the time, but yeah. Okay.
Do we have any questions for Cheuk?
Great question.
It feels like the version of Python is going to make quite a big difference, because like Python 3.12, I think it's got a just-in-time compiler that's part of it, and also Python's sort of moving towards allowing strong typing, which I assume is going to make those, that problem you're outlining at the end better. So
that's a very good point about 3.11. 3.11, if those of you who haven't tried 3.11, 3.11 actually has a speed improvement from 3.10. And actually, if you read the notes about the release notes, there's a lot of changes in 3.11. And at this moment, Numba still doesn't support 3.11 because there's too much change in the Python core itself. So, but yeah, like you made a very good point. So maybe if you can change it to 3.11, you can also try that and compare which one works better for you. So, yeah.
Oh, the question here.
What is the reason that you never look into supporting Panda? Or is it something that's technically preventing you from doing that?
Yeah, actually, but everybody told me that the Panda inside they use Numba, right?
Yeah, you can set the engine in Panda to use Numba, but
Yeah.
you still have the same constraint in terms of the code need to be written in a way. So you write apply function, that function need to be able to be written in Numba compatible format.
Yeah, it's because Numba, so pandas, we all know that Panda underneath is use NumPy, right? So I'm pretty sure that Panda already have optimization for the NumPy operation underneath. But the thing is that because Numba itself, for example, this like all this JIT and like ngit and stuff, so this ngit is designed to compile the code that use NumPy and all these like mathematical calculation. So if you put something like that is an object, the Python object that it doesn't understand, because in Python you can define your own object and all that stuff, right? So even though Panda is a very popular library, and there's like, Panda's data frame, we all use it and love it, but Numba is not designed for that. So when it sees an object, for example, Panda's data frame, then it's a type of object that it's not designed to compile it, so it won't compile it. Any more questions?
I have one.
Oh, cool.
How have you found this comparing against things like PyPy or Python?
Yeah, very good point. So there are other things that you could potentially use to speed up your code. Python is I think I've tried to use it a little bit years ago. Python you can also make your code kind of C compilable. But I feel like personally, you may disagree, that I feel like Numba is quite easy to use compared to Python, because Python you have to again make all these adjustments and all this decoration to be more specific about how your code can be compiled. It's just my opinion. I think Numba is more straightforward and you don't have to make that much changes to your code. But I could be wrong because I haven't used Python for years now. So.
Yeah. And would you say that every function has to be a pure function in order to get it to work?
It needs to be have some mathematical calculation here using NumPy. So of course you can 1 + 1 you can also speed up. That's very simple. But the start of the show here is that if you have some NumPy object, it will understand it. So you see that even the vector operation, it still got the speed up. It's not like, oh, I should not use it with the vector operation. I'm gonna die. So yeah, so even the vector operation with NumPy will still speed up. It's just that the speed up is not as much if you compare that with the element-wise one here. Is that a question? Yes?
Yeah. So how compatible is Numba with most of the higher level scipy functions? Because most of those underlying still NumPy.
Underneath.
The scipy functions like the scipy distribution functions and statistics functions.
So for those, I haven't tried myself actually, but if you say that if the object itself is a NumPy object, even though the operation is SciPy, maybe it will still work. But the thing is, the thing that it doesn't work with Panda is that because the Panda data frame is a completely different Python object. So if the function underneath is all use some NumPy objects, then it may got the speed up, but I have to try it to tell you for sure.
Thank you.
Yeah.
Do we have any other questions?
So how does it type the input? And do you have to always score with the same types?
The same types you mean?
Like just a function that adds numbers. Does it, if you call it with integers,
So
can you call it with floats later?
There's the thing that because when it got compiled, it needs to know what the type of the thing is. So the problem here is not that, because I mixed the type, because it just assumed that because when you define it, you didn't specify the type here. So it just assumed that it's an integer for those two. So there are also other wacky exercise that I add here is that, for example, if you have empty list, then you will come into problem using ngIf because again, an empty list, it could be anything inside. So Numba will be freak out when it compiles. So you have to kind of somehow tell Numba that it's actually I'm only storing integer in this list, something like that. Yeah.
Do we have any other questions? No? Okay, well, thank you very much. Thank you.